We have already talked about work and kinetic energy. Let us now introduce a new type of energy, the potential energy. Let us now think about an object that is thrown vertically. In this case, the force of gravity reduces the speed of the object, makes it stop and fall back down. In this process, the kinetic energy goes from being maximum where the speed is maximum to being zero up top, and then increases as it goes down. We can calculate the work done by the force of gravity, F delta y, where F is mg and delta y is y final minus y naught. From the work energy theorem, we know that this is equal to the change in kinetic energy, 1/2 mv squared. This term here, we call it the potential energy due to gravity, so gravitational potential energy, mgy. The potential energy depends on the relative distribution of the particles of the physical system. In this gravitational case, it is the height of the object, the relative position of the object with respect to the surface of the Earth. But the concept of potential energy is more general. Think about two electrons that they repel each other. Now, if you put them close, the repulsive force will be larger than if they are far apart. Therefore, the potential energy stored in the system is larger when they are closer, as once released they will have a larger kinetic energy. In the case of a spring, the more it's stretched, the larger the kinetic energy the mass can gain once released. Therefore, the higher potential energy is stored. Again, the potential energy depends on the relative position of the elements of the system. If we put both terms of this result on the same side of the equation, we see that the change in kinetic energy plus the change in potential energy is equal to zero. Kinetic energy plus potential energy is conserved in this case. In fact, there is a more general principle named the principle of conservation of energy that says that the energy can be transformed from one kind to another, but it is always conserved. In this particular case, the initially high kinetic energy is being transformed into potential energy as the object gains height. At the top of the trajectory, the object has no kinetic energy. It is at rest. There, the potential energy is maximum. When it starts to fall down, it increases the speed, increasing the kinetic energy, while it loses potential energy. Look that we found an equation for the difference in potential energy. We are always going to measure differences in potential energy. We can choose our origin of coordinates wherever we want, as usual. If we assume that y naught is 0, then the change in potential energy is given by mgh, where h is the height gained by the object. If we choose the origin of coordinates to be at the center of the Earth, then the final y is the height plus the radius of the Earth, and the initial y is the radius of the Earth. This leaves us with the difference in potential energy is still mgh. Let's do an example of conservation of potential plus kinetic energy. Consider Tarzan, the grabs a vine, hanging vertically from a tall tree, when he is running at 9 meters per second. How high can he swing upwards? To the sum of the potential plus kinetic energy, we call it the mechanical energy. This mechanical energy is conserved in all the processes. So the initial mechanical energy is equal to the final mechanical energy. In this case, the initial velocity is 9 meters per second, the initial height is 0, the final velocity is 0, as at the maximum height it is at rest, and the final height is h. We solve this equation for the height and we get that it's equal to v squared divided by 2g. This gives us 4.13 meters. Of course, there are aspects that have not been considered, such as friction. Friction is always acting against motion, and when we talk about energy, it removes energy from the system. This means that Tarzan will have a bit less energy at the end because part of the initial energy has gone to the environment. This still satisfies the energy conservation. The initial kinetic energy of Tarzan has gone into the potential energy plus energy dissipated to the environment. and it all is conserved. In this case, it is not too much of the initial energy that is dissipated though.